Okay, we're back. Again, I want to thank Rob for a really fantastic presentation that really sets the context for what happened in Colorado. And our next speaker is Paige Tucker, who's CEO and president of a company called ProStar, which is based in Grand Junction, Colorado. And this is what I call a mobile and cloud solution that was adopted by the Colorado DOT. And I believe at this point is required of anybody doing work in the public right of way in Colorado, so that all the information captured by exposing utilities, or for new utilities going in the ground, or for anything that relates to underground utilities that can be captured, now goes into the system and can be shared by everybody involved in the construction process. So I'd like to hand it over to Paige Tucker to talk about how his technology has been used in Colorado, but also how it can be used for creating a digital twin of the underground. Paige, it's your floor.
Sounds good. I take it you can hear me, no problem. Can you hear me?
Yes, we can hear you.
Okay, perfect. Well, thank you so much, first of all, for that introduction, Jeff. I really appreciate it. I think Rob did a pretty eloquent job, maybe even better than I can do on promoting ProStar. So what I'm going to talk about, and what you alluded to, is how to create a digital imprint of the underground, leveraging modern technology. Just kind of go through where the state of the industry is today, discuss a little bit about some of the influencers that I refer to that are adopting our technology, and where I see things going over the next couple of years. In fact, so that we can get to the point where we have a digital imprint of the underground. So a digital underground, leveraging modern and cloud mobile technology to create a digital underground that provides the ability to see the precise location of buried utilities and pipelines, and securely share that information when and where it is most needed. One of the most important and critical components of having a digital footprint, if you will, of the underground, and being able to share that information. Obviously, security is very important, and I'll touch on that in a little bit. Let's just take a look at, when we talk about infrastructure, particularly in the United States, and there's quite a bit of campaigning coming out of the White House right now talking about infrastructure. There's 2.4 million miles of paved roads in the United States. And of course, we rely on that to transport our goods and also for commuting. We now know that this infrastructure is becoming dilapidated and in serious need of repair and replacement. I mean, all countries are facing this. It's no different here in the US compared to Canada. The White House is estimating that it's going to take about $1 trillion just to get a small portion of the roads, bridges, and highways up to levels that can support the demand. But inside that bill, they're also looking at repairing and replacement water systems, sewer systems, and expanding broadband. So the point is that the bill of infrastructure is not only focused on surface infrastructure, but also subsurface infrastructure. And I would argue that they're twins and that they're directly connected with one another. The American Society for Civil Engineers basically estimates that it's going to take at least $2.5 trillion over the next 10 years to get our roads and bridges and railway systems up to levels that can support demand. So although the White House is earmarking about $1 trillion, that's only touching the surface of what would be required. I like to show this image because, as I mentioned, there's an infrastructure twin. That's the subsurface infrastructure, or what I call the other infrastructure, which is basically out of sight and therefore out of mind. But you can see what it looks like. This is an example if you removed all the pavement downtown New York, but this would be no different on Bay Street in Toronto or Howe Street in Vancouver. It's basically what I call a spaghetti bowl of utilities and pipelines that have been haphazardly slapped into the ground over a period of over 100 years. In fact, well over 50% of the infrastructure that's buried below the ground was put into the ground over half a century ago. And if you think our surface infrastructure is becoming dilapidated and in serious need of repair and replacement, I would argue it pales in comparison to what's below the ground, because we really don't know what's going on below the ground because we can't see it. And often by the time we know that there is an issue, it's too late. In fact, here's some statistics. So there's 35 million miles of buried utilities and pipelines in the United States. And over 500,000 times a year, those utilities or pipelines are hit during construction or repair of the utilities and pipelines. That equates to about a strike every minute of every working day. And that number's growing anywhere between 16 to 19% per year. So it's only getting worse. And yet 100% of all construction projects are required by law to identify where these utilities and pipelines are before any digging can occur. In the United States, you have click before you dig, and in the US, we have 811, call before you dig. It's estimated there's $10 billion spent in the US every year trying to identify where these utilities and pipelines are prior to construction. And yet we have over $30 billion of impact on our economy as a result of damages to utilities and pipelines during construction. So arguably, whatever we're doing, it's not working too well. There's a great deal of stakeholders that are impacted by the subsurface infrastructure. And here I just show a few, but basically it's engineering and surveying companies, oil and gas, utilities, even municipalities. Down here we have Department of Transportation, of course, in Canada. You have Ministry of Transportation, also the construction companies, and even the companies that are contracted to go out and locate where these utilities and pipelines are. I think Jeff alluded to that one of the issues that we have is how we're capturing this data and how we're managing the data. First of all, over 50 years ago, when a majority of the utilities and pipelines were put into the ground, there wasn't a great deal of regulation or compliance like there is today. But even over the last half century, the way that we've managed the data is based on as-builts. These are the original planning and design drawings of where these utilities and pipelines are intended to go into the ground. But how they go into the ground and how they were planned to go in the ground can be two completely different scenarios. And it's a result of anomalies and all types of conditions once we get out into the real world where we're going to place these utilities and pipelines. Maybe the ground is too hard. There could be other obstacles in the way where they plan to put in the utility. Maybe there's already too many utilities there. Plus the contractor has to place these into the ground in a timely manner. That's how he gets paid and that's how he's profitable. So he's going to take the path of least resistance. So they always don't go into the ground the way that they're planned to go into the ground. And yet the information that we rely on to identify where these utilities and pipelines are in the ground are actually based on these as-built drawings. So by nature, they're not correct. The way that we identify where utilities and pipelines are is we call into click before you dig or 811. The center takes the information that was provided to them by the utilities or pipelines at where they best knowledge of where they think their utility lines are. And then the center notifies the utility and pipeline companies that they have to go out and mark where their utilities are so that the construction crews and the excavating crews can avoid hitting those utility lines while they're digging. What they do is they send out locators, which are utilizing these electromagnetic locate devices, which are designed to locate the utilities and the pipelines. Once they've identified where the utility is, then they mark it with a paint mark that is color coded to represent the utility line. So if it's red, it's power. If it's blue, it's water. If it's yellow, it's gas. It's industry knowledge that at best that marking is accurate to within 1 meter. That's the variance because of course there could be human error involved in this. In addition, you don't really know which utility he actually identified, and if it was the right utility, or if he even identified a utility at all. This practice has been going on for well over 2 decades, and it's gotten to the point where the construction and engineering companies and the excavators realize that they can't rely on those markings because they're the ones that actually take on the risk and the liability. So to provide a better source of information, what they do is they'll bring in what's called hydrovac trucks. In Canada, one of the biggest companies is Badger that actually has over 35,000 trucks in operations. And that number's growing. But what they'll do, they bring these trucks out and they'll actually drill a hole in the pavement right over top of these markings. And they'll suck the dirt out through that huge vacuum system and then look down and see if they can actually see where the utilities are. It's called daylighting. If they don't find the utility that was marked, then they'll move over a little bit and they'll dig another hole in the pavement and see if they can identify where the utilities are. We're doing a project through I-70, which is the I-70 project, excuse me, it's 11 miles of expansion through Denver. It was one of the projects that Rob Martindale alluded to, and it's Kiewit that is actually doing the construction on that project. To date, they've dug over 33,000 holes. That number is going to grow because the project is going to continue for a longer period of time. But that's a lot of disruption, number one, on the pavement. It makes a mess. It's a very onerous process. It's a very expensive process, and it's also very time consuming. This is an example of how many utilities you can fit within 1 meter, and that's part of the problem. As you can see here, our underground corridors are becoming very congested. We're putting a lot of utility lines into the ground, and that is only growing each year with more demand and population growth. But this just gives you an idea of how many utilities you can stack beside each other and on top of each other in a very small confined area. In addition to that, part of the problem is the ability to share information in a timely manner and in a standardized format. This is the current workflow process. You identify where the utilities are, either through the electromagnetic locate tool or the hydrovacing, and then you send engineering and surveying crews out there to survey in the markings or where the holes are. Then you upload the data to a PC out in the field. That data is qualified by someone out in the field. And then they export the data back to the office where it's imported into a computer-aided or CAD system or GIS system, once again qualified by the CAD or GIS department manager. And then that information is then provided out onto the project site where it's most needed so they can make more intelligent business decisions. This can take up to 2 days, 2 weeks, even 2 months. So what we did is we developed a solution that can address, I call all of those dated and archaic workflow processes and business practices that have been well entrenched into the construction industry for over 2 decades. In fact, it's a well-known fact that the construction industry is a lagger when it comes to adopting modern technology. But today, I'm not here to promote our product. I'm here more to talk about just where I see the industry going and the transformation by adopting and leveraging modern cloud and mobile technologies. So here's our process, and it's pretty simple. Basically, we take the electromagnetic locate tool and we pair it to any standard mobile device, mobile phone or tablet that you can go buy at Rogers, that's running our mobile app called PointMan. Then that pairs to a precision GPS receiver, which will provide centimeter accuracy. So it's not utilizing the GPS that's embedded into the device, which is accurate to about 1 to 3 meters on average. And then we take all the information that's been collected and we push that up to the cloud. Our cloud's running on AWS. That's where we do all the post-processing, all the calculations. We run it against proprietary algorithms that we've created. And we make all that information available in real time. That's done in less than a second. This is what it looks like as far as how we're collecting the data and the data that we're capturing. So When they're out collecting the utility line or the pipeline using the electromagnetic locate tool, what we do is we're pairing it to a standard mobile device running our software called PointMan. And what we're doing is we're actually digitally capturing where the utility line is. And as you can see in the gentleman's right hand, it's never a perfectly straight line. It's more like the trail that a serpent leaves in the desert. Also, it's never perfectly, say, for example, 1 or 2 meters in the ground based on what the regulation is. Sometimes it could be 1 meter in the ground, half a meter in the ground, quarter meter in the ground. And again, as I mentioned before, a lot of times that can have to do with the soil conditions. But what we're doing is we're also capturing all the metadata that's available from that locate tool and also from the GPS receiver. So for example, you can see we're capturing what type of locate device is it, what's the depth, what's the currency and the frequency, what type of receiver were we using, in this case, the Trimble R10, date, time, vertical precision, in this case is 1.3 centimeters. We even provide the metadata so that you can identify how we came up with that type of accuracy. So for example, how many satellites are in view, in this case 9, which constellations. And then we can also provide the NEMA string, which is the information or the data coming off of the satellites that determines the accuracy. The other thing we do is we are a data aggregation system. So we can integrate into all of the systems of record that provide this information from the utility owner or the pipeline owner or the construction company. So for example, in this case, we can stream the data in directly from the utility company of where they think their utilities are. And then based on the information we've captured, which is the actual location, we can see what the discrepancy is. Then what they can do at a click of a button, they can import the data of where the utility line actually is, and they can update their records. So the more data we have and the more companies that are contributing in this process, then over time, the digital information of where the utilities are actually buried continues to improve. So our workflow process is pretty simple. Capture the data, goes up to the cloud, and it's available out into the field or the office to anybody that needs that information in real time, including the construction company, the engineering company, even the excavator. Here's some of the companies that are adopting our software. I call them major influencers. So Kiewit's the largest infrastructure construction company in North America, Fortune 500. As Rob mentioned, CDOT has mandated our software in the state of Colorado. So anyone that's involved in either owning or the construction or the management or maintenance of a utility or pipeline that's on a state right-of-way by law is required to use our solution. KCI, which is one of the largest subsurface utility engineering firms in the US, was an early adopter of our software. But as a result, just over the last month, we've got companies like T2, which is a major subsurface utility engineering firm based in Canada, Kramer, a large construction company. Zayo is one of the top fiber optic companies in North America with operations in the US and Canada and the UK. And then Bloodhound is actually the first locate company that I know of that's adopted a software that will actually digitally capture the precise location of where the utility or pipeline is buried and then share that information with the actual utility owner. And Bloodhound is a subsidiary of United States Infrastructure Corporation, which is the largest utility locate company in North America. So we're starting to see that adoption into the market as a result of some of these early adopters and what I call influencers. We also partnered with Trimble. Trimble allowed us to have the highest level of integration into their GPS and GNS receivers than any other company in the world. If you're not familiar with Trimble, they're the world leader in the manufacturing of GPS and GNSS equipment and surveying and engineering equipment. So again, this is another major step in influencing the industry to go digital and capture precise information. We've also partnered with all of the major GPS and GNS equipment manufacturers around the world, and also all the major electromagnetic locate tool manufacturers. Why do they adopt our software? Well, we improve the productivity and performance of their equipment, and we also enhance the user experience for their customer because everything we do just works off a standard mobile device that the customer, probably already has in their pocket. This is an example of where technology is going. One of our industry partners, Vivex Metrotech, has actually taken the precision GPS receivers that were normally provided by third-party companies, and they've actually embedded it into the locate tool device. So this is the RTK Pro. So this locate device actually captures utility location and pipeline location down to the centimeter. And when you couple that with our mobile device, now you have a digital record of precisely where that utility is located, as opposed to just putting a paint mark in the ground. We're also working with a company called Prism. What Prism provides is a 3D gyroscope that creates a digital geospatial representation of the location, the geometry, and the bend radius of utility systems down to the size of a 3.2 centimeter duct. So that little gyroscope there is about the size of a pen that can go inside the utility line, and then it'll map it out down to the centimeter, including the bend radius, and give you a profile. So we're working with Prism to integrate that so that we can capture that information in real time digitally and then provide that to all the stakeholders. So what do I think is next? Well, I think what we're going to see over the next maybe even 12 months is leveraging all these advancements in technology to provide a three-dimensional digital view of the precise location of buried utilities. And what we're going to do is we're going to be leveraging the modern technology that's already available to us today. There's nothing that we have to wait for. It's just all about integrating this into one seamless solution. So for example, taking what Vivex just created, which is the locate tool that has a precision GPS receiver embedded into it, and then capture that information, say for example, on our mobile app, PointMan, and then provide that information to a new technology that's now provided by Trimble, which is Sight Vision with the Catalyst receiver. What that is, that's a handheld augmented reality tool that has a precision GPS receiver built into it. So when you're out locating and we're capturing all this information digitally on PointMan on the mobile device and pushing that up into the cloud, then you make that information available in real time to someone that has the Sight Vision augmented reality device in their hand. And what that would provide them immediately is a 3D view of all the utilities that are buried below the ground with accuracies down to a centimeter. So basically provides the ability to see what lies beneath the ground in real time, but more importantly, with centimeter accuracy. If you don't have the accuracy, then it's just another pretty picture. The advantage to that is then we could then share all that information in real time, say for example, to the excavator, to their heads-up display system. They would then also receive this information in real time. And if there was a utility line that he did not know was in the area, especially within the area that he was digging, then it could provide automatic notification to them in real time that they need to call and have someone come out and identify where that utility or expose it to reduce the chance of damaging that utility by hitting it. Getting down to where I close, one of the big questions that comes up, this is great. You're going to have all this information, you're going to have digital records of it, and you're going to have all these stakeholders that need this information. But what about security? And I would argue that the utility and pipeline industry and construction industry is more sensitive about their data than the Department of Defense or the financial industry. And when you think about it, when I said this industry is a lagger, all other major industries have moved over to cloud and mobile technologies. And of course, one of the things that they've addressed, which is one of the most critical issues, is data security. In fact, I would argue that having digital information is far more secure than having it the way that we're managing the records today, which in most cases is based on paper records. But every day you think about it in our daily lives, we're ordering goods on Amazon. I can even take a picture of a check and it will automatically show up into my bank account. That's because security protocols have been put into place. And if you follow those security protocols, then the data itself is very secure. In fact, we've moved over to the most modern platform, which is AWS. Might surprise people that we're serverless now. A lot of companies are trying to get over to VM, which is virtual machines. We don't even have servers anymore. So I don't even have a department that manages the servers. And our solution is available anywhere in the world, any continent, any language, any currency, because that's where modern technology is going. But the point of it is we can address data security. Ourselves, we just were awarded SOC 2 compliance, which is the highest level of security that you can attain in the US. Now we're going after being able to achieve the same level of security protocol for other countries, particularly in the UK. Just want to let everybody know that Point Man is available on Google Play or the Apple Store. It's free. You can download it. You can use it. The one that you get on Google Play actually allows you to have the Precision app, and it gives you a 30-day trial. But for anybody that's on this call, if you want to download it and extend that trial, feel free to call me personally. I want everybody to be out there and trying it and at least understanding where we're going as far as the ability to capture digital information on these buried utilities and pipelines. And that concludes my my presentation, and I'll take any questions if you have them.
Paige, thanks a million for that. I think that gave people really a clear introduction to what a cloud and mobile solution looks like now in the utility industry. As you said, cloud and mobile is not new for many other industries, but for construction, because construction is a little bit behind some of the other industries. One of the questions that we got, and was also a question I had, was who owns the data? And to put this in context, you mentioned that you have contractors using this data, Kiewit, KCI, so on. CDOT uses this data. You didn't mention a particular utility or telecom that has acquired this system, but that you did mention that the data could be made available to a utility or telecom that, you know, if they wanted to correct their as-built, which, as you said, are usually not very reliable. So if you look at the system, let's just look at the system in Colorado. You've got CDOT involved, you've got Kiewit involved, you've got locators involved, you have utilities involved. How do you manage the data sharing aspect? This usually requires legal agreements.
Yeah, that's a great question. Number one, and you just brought it up, one of the things that we had to do in the state of Colorado, and why I think kind of state of Colorado is such high profile right now, is that we had to get all the stakeholders involved. So I shared some of the stakeholders, but as you mentioned, we also had to get municipalities involved. I actually had to meet with senators and state lawmakers, 811, because it was the whole universe of all the stakeholders. So that was number one. We were able to be able to ensure everyone that this system is not disruptive. Number one, it works with any technology that's out there, regardless if it's software or hardware. So a lot of these companies have made huge investments, you know, in legacy hardware and software, and they don't want to reinvest. So number one, you have to have a system that will work with all the current systems that are in place. But the second question that you mentioned or alluded to was who owns the data? We always ensure the stakeholder, be it the utility company or the construction company or the engineering and surveying company or the municipality, that they own the data. It's their data, and at any time they want the data back, we provide it back to them. So we don't want to be in the position where we are actually maintaining and managing the data and sharing that data and charging for the data. The stakeholder can determine, number one, who gets that data, how long do they get to view the data, can they edit the data, is it view only? And that's the way we've set up the system, which is called roles and privileges. So I just want to give you an example. On a project, let's just say that utility ABC says, okay, I'm going to share my information on that project, but only for a limited time. Well, what we can do is we can geofence the project area, so it's only the data within that confined area. And then we can actually limit it. So if there's like 1,000 people on that project, maybe there's only 4 people that actually need access to that information. And maybe there's only 1 that has the ability to edit that information in case the utility owner wants to update their record. So it's unlimited, based on what we call roles and privileges of who gets to see that data, how long do they get to see that data, do they get to edit the data, do they get to view it only? So you can put almost unlimited restrictions on it.
That's very clear the way you explain that, because that is key. You know, the question that usually comes up for these kinds of things when you have telecoms involved is often called data protection, but pretty well what you described. And because telecom is so competitive, they really don't want anybody to have the ability to see their entire network. You know, there's usually some restrictions that limits who and how much and how frequently data can be seen. And it sounds like what you described would allow, you know, with geofencing, for example, would allow something like that to happen to protect telecom operators.
Yeah, one of our clients is, as I mentioned, is Zayo, which is, I'll call the early adopter of our technology. They're one of the largest fiber optic companies in North America. And I can tell you, if anyone is sensitive about their data, it's the fiber optic companies.
Great. Now I've got another question, which is an interesting one. This is from Monica Beaton, who is a municipal GIS manager.
Yeah.
And what she's asking is, what's a good approach for gaining buy-in with upper management for adopting technology like you've described?
Yeah, it's a good question. So number one, we're working with several municipalities right now. And the key to it is that a lot of municipalities, not all, have made a big investment already in a system of record. You know, perhaps I'll use Esri as an example, which does a great job as far as geospatially, you know, managing their assets. But what our system is specifically designed to do in that case is that we integrate seamlessly in with the Esri system, and we have the ability to go out and in real time manage, number one, the workers that are out on the project that are capturing information, but number two, aggregating all the data that they need. For example, here in the state of Colorado, because there's a CDOT mandate, well, what we can do is then we can share all of the CDOT data in real time with the municipality, because how municipalities manage DOT data when they're on the DOT right away is completely different based on how they might manage it based on their own municipal regulations. So the key that what we provide is, again, that data aggregation. So for upper management with a municipality, this is the way that I would explain it in simple terms. We can take all the systems and business practices that they currently have in place and literally put it on steroids, literally enhance the operations, make them more effective, more efficient, and more importantly, more accurate. And that's the way that I would sell this, is that we can be a bolt-on to their current practices. They don't have to replace what they're doing, but for a very low cost, and we are, by the way, we can significantly improve their current business practices and workflow processes. And when I showed you a list of clients that we have, that's actually what we're doing. They're not changing anything. We're just coming in and giving them a lift and leveraging modern technology to improve their current business practices. We're working with several municipalities now. I expect in upcoming just few months, we'll be able to announce the municipalities that we're working with, and then we'll be able to provide, you know, return on investment on what we're doing. Like, I'll give you an example. With Kiewit, it took us a year to be able to really quantify and measure what we're doing for them. And one of the things that we did for them is we've reduced utility strikes on major projects by upwards to 90%. Well, that's a cost savings in millions of dollars just on the utility strikes, not to mention the downtime on the work crews that we eliminated. So there's going to be some measurable and quantifying statistics that we have coming out. And one of the things that I do want to do is work with municipalities, because that's just one of the markets that we haven't moved into yet. I'm in discussion with several companies or municipalities here in Colorado as a result of the mandate. So I expect to have some more quantifiable results on the impact that we have on municipalities very soon.
Thanks a million, Paige. That statistic from Kiewit is remarkable. I mean, the ROI in that has got to be a no-brainer. You don't even have to calculate that one.
No.
Reducing damage by 90%, that's incredible.
Yes.
So anyhow, Paige, thanks a million for your presentation. I mean, I think this really gave people a picture of the state of the art when it comes to mobile plus cloud solutions in the construction industry, specifically for things relating to the underground. So
Great. Well, I appreciate your time. Thank you so much.
thanks a million.